So while studying the topic called range, a projectile motion, I told you the maximum range will be always at the value of theta, that is 45 degree. So in the question itself it is given that the value of acceleration due to gravity as 10 meter per second square. Range can be calculated by the formula u square sine 2 theta divided by g. Hello everyone, welcome to session 6 of chapter 4, Motion in a Plane. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. In the last session, we have solved few numericals based on motion in a plane and various formulae what we have come across in this chapter. So in this session, let us solve few more problems. So let's start with a cricketer can throw a ball to a maximum horizontal distance. What is maximum horizontal distance? It is nothing but the range. So to a maximum horizontal distance of 100 meter, how much high above the ground? What is the maximum height they are asking, or what is the displacement they are asking to find? How much high above the ground can the cricketer throw the same ball? So here we have range is equal to 100 meter and h we have to find out. So how to find h, or what is the formula to find range? So range is nothing but u square sine 2 theta divided by g. Here, so while studying the topic called range, a projectile motion, I told you the maximum range will be always at the value of theta, that is 45 degree. So here they are saying the range is maximum and theta must be 45 degree. So this expression becomes r is equal to u square sine 2 into 45 divided by g. So what is 2 into 45? It is r equals u square sine 90 divided by g. Sine 90 value is nothing but 1 and we remain with u square divided by g for maximum range when theta is equal to 45 degree. So what is u square? We have to find out u square now. So range is 100 meter, it is given. So 100 is equal to u square divided by 9.8. So multiply these two and take the square root for u value and you will get the value as 31.3. Since we are finding it velocity, the unit must be meter per second. So now they have even asked us to find the displacement of the ball or the maximum height. So we can use the third equation of motion, that is v square minus u square is equal to 2as. Here final velocity is not given and the initial velocity is 31.3 the whole square, which is equal to 2 into acceleration. Since the ball is projected upwards, the g value is negative conventionally. So g value is 9.8 and it is with the negative sign, and s is nothing but the displacement. So solving these values, we will get the value of s as 49.9, which is almost equal to 50 meter. So the cricketer can throw for up to 50 meter high the same ball. Let us now move on to the next question. The ceiling of a long hall is 20 meter high. The ceiling of a long hall is 20 meter high. What is the maximum horizontal distance? Means the range that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the hall. Means up to what range ball can travel inside the hall without hitting the ceiling, that is what we have to find out. So in the question itself it is given that the value of acceleration due to gravity as 10 meter per second square. So let us now use the data which is given in the question and find the value for the required task. So height of the ceiling is given, that is 20 meter, and velocity is 40 meter per second. The value of g, that is acceleration due to gravity, is 10 meter per second square. So maximum height can be calculated by the formula u square sine square theta divided by 2g. Here we have h is equal to 20, which is equal to u square. So we have u value as 40. So 40 square sine square theta divided by 2 into g. So g value, if it is given in the question as 10, let us take the value as 10 itself. If it is not given, then the value is 9.8. So you can either simplify by taking it as rounding off it to 10 also. So now we want the value of theta. So let us now retain the theta term and we will solve the rest of the terms. Here 2 into 10 is nothing but 20. So we can write 20 equals 40 square sine square theta divided by 2 tens are 20. So now cross multiply this, you will get 400 which is equal to 40 square 1600 sine square theta, or we can write it as 400 divided by 1600 which is equal to sine square theta. We can say that 1 divided by 4 is equal to sine square theta, or we can write it as sine theta is equal to root of 1 divided by 4, or sine theta is equal to 1 divided by 2. So from this we can find the value of theta, that is theta is equal to sine inverse of 1 by 2, which is nothing but what is the value where we get 1 by 2 in trigonometric table of sine function, that is at 30 degree. So the value of theta is 30 degree. This is how you have to make use of the given data in finding the answer. So here sine square theta is equal to 1 by 4 and sine theta is equal to root of 1 by 4, that is 1 divided by 2. So theta is equal to sine inverse of 1 by 2, theta equals 30 degree. Now maximum range you have to find out, which means up to what distance along the horizontal does the ball can travel without hitting the ceiling, which is nothing but range. So it is given by the formula u square sine 2 theta divided by g. Now u is nothing but 40. So let us now substitute all the values. R is equal to 40 square sine 2 into theta value is 30 divided by 10. So now 2 into 30 is nothing but 60. Sine 60 is nothing but divided by 10. So sine 60 value is nothing but root 3 divided by 2 and divided by 10. So simplifying this, we will get 138.56 meter. It is nothing but the range of the ball, which means the ball can travel up to 138.56 meter without hitting the ceiling. So let us solve the next problem now. A cricket ball is thrown at a speed of 56 meter per second in a direction which is making an angle of 30 degree with the horizontal. We have to calculate the maximum height, distance from the point of throw to the ball returns to the earth, as well as total time taken by the ball to return to the earth, which means we have to find out the maximum height, the range, as well as the time of flight. So let us now write the data. U is 56 meter per second and the value of theta, which means angle of projection, is 30 degree with horizontal. So we are mentioning with x-axis, and height, range, time of flight we have to find out. Maximum height formula is u square sine square theta by 2g. So we get 56 square sine square 30 divided by 2 into 9.8. So sine 30 value is 0.5 because sine 30 is 1 by 2. So 0.5 into 0.5 because it is sine square into 56 square divided by 2 into 9.8, that is 19.6, which gives you 40 meter. So 40 meter is the maximum height a ball can reach. So next we have to find out the range. Range can be calculated by the formula u square sine 2 theta divided by g. The value of u is 56 and hence it is 56 square sine 2 into 30 divided by 9.8. So this is nothing but 56 square sine 60. Sine 60 value is root 3 divided by 2 divided by 9.8. So simplifying all these, we will get 277.12 meter is the maximum horizontal distance that a ball can travel before it hits the ground. Now we have to find out the total time taken by the ball before it hits the ground, that is calculated by the formula time of flight, which is given by 2u sine theta divided by g. So 2 into u value is 56, sine 30 divided by 9.8. Sine 30 value is 1 by 2, that is 0.5. So 2 into 56 into 0.5 divided by 9.8 gives us the value 5.71 seconds, that is the time of flight value. So let's move on to the next one. A bus of mass 5000 kg moving at 72 km per hour, which rounds a curve whose radius of curvature is 500 meter. What is its centripetal acceleration and centripetal force? So the formula to find centripetal acceleration is so easy and we are all familiar with that. That is A is equal to V square divided by R. It is given that the mass of the bus is 5000 kg and the velocity of that bus which is moving is 72 km per hour, and we can convert this into meter per second. So how to convert? Velocity is 72 km per hour. So which is nothing but 72 into 1 kilometer is equal to 1000 meters into 1000 divided by, we have per hour, so 60 minutes in hour which has 60 seconds each, and we will get 20 meter per second. Simplifying this, we will get the velocity as 20 meter per second. And also it is given that the radius of curvature is 500 meter. We have to find out the centripetal acceleration and the force. We have to find the centripetal force. So to find centripetal acceleration, the formula is V square divided by R. So V value we got, that is 20 meter per second. So we can write 20 square divided by radius of curvature is given, that is 500. So we will get 0.8 meter per second square. Since it is acceleration, the unit must be meter per second square. So and we have to find out the centripetal force. Centripetal force is nothing but, force formula is m into A. A is the centripetal acceleration. So in the place of acceleration, we can write V square divided by R, and hence the formula for centripetal force. So let us now substitute the mass, that is 5000 into V square divided by R is 0.8. We will get the value as 4000 Newton. Since it is centripetal force, the unit of force is Newton. So next we have two forces of magnitude 25 Newton and 45 Newton. These are the two forces given whose magnitude is 25 Newton and 45 Newton. Act at an angle of 60 degree. Find the resultant. We have to find the resultant of these two magnitudes. So here F1, that is first force, force 1 is given by 25 Newton, force 2 is given by 45 Newton. The angle between them is given by 60 degree. We have to find the resultant force. How to find the resultant force? Which is given by the formula, that is A square plus B square plus 2PQ cos theta, or we can write it as B. Here we have taken the terms as F1 and F2, and we can write the same as root of F1 square plus F2 square plus 2 F1 F2 cos theta. Let us now substitute all the values. F1 value is 25, F2 value is 45, so it becomes root of 25 square plus 45 square plus 2 into F1 25, F2 45 cos 60. So what is 25 square? It is 625. 45 square is 2025 plus 2 into 25 into 45 gives us 2250, and cos 60 value is nothing but 0.5. Why? Because cos 60 is nothing but 1 by 2. 1 by 2 is nothing but 0.5. So substitute everything and multiply 2250 with 0.5, when add the answer with 2025 plus 625, and you will get the resultant force as root of 3775, and the square root of 3775 is 61.44. Since we have calculated the resultant of forces, the unit must be Newton. Now we have calculated the magnitude of the resultant. Let us now also find the direction. So direction can be calculated by the formula alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. Here it is nothing but tan inverse of F2 sin theta divided by F1 plus F2 cos theta. So here F2 value is 45, sin theta value is 60 divided by F1 value is 25, F2 value is 45 cos 60. So we will get tan inverse of 0.8205. So this value can be obtained from the logarithmic tables. We can make use of natural tangent sheet in the logarithm tables to find the answer for this, and that gives us 39 degree 22 minutes. So the resultant force is 61.44 Newton in the direction of 39 degree 22 minutes. These are few examples for numericals from the chapter motion in a plane. In the next session, let us discuss about another new chapter. Until then, all of you please take care. Thank you.